Hello, welcome to Emanate, wherever you are joining from. Just a little introduction about Emanate. We are a community for the professionals working or aspiring to work in the sustainability sectors. What we are doing are we're holding webinars almost every month, and we cover a wide topic in the sustainability sector, such as renewable energy, energy efficiency, and any other efforts towards climate change mitigations and environmental management. So our webinars are accessible for everyone, even though, you can go to our website that you can find in the description sections, and also we have our LinkedIn page and our Facebook groups that we invite you to join. And this afternoon, our webinar is going to cover about life cycle assessment and its applicability in for the sustainable production. We're going to cover about agricultural sectors, circular economy, and also in energy. And with us, we have 5 speakers, including myself. And we will have Patricia, who is going to present about the overall overview about LCAs. We also have, she's also going to present about the applicability in agricultural sector. We also have Joanna Perez, who is going to talk about circular economy and also the implementation of LCA in circular economy. We will also have Cecilia, who is going to talk about LCA in the solar PV sector. And we have myself and Salva Burhan, who are going to be the other panelists of this webinar. So maybe we will start with, our self-presenting. What is it that we are doing in our professional life? So I give the floor to Patricia.
Hi, everyone. I am Patricia. I am an industrial engineer. I have previous experience in production planning and warehouse management for pharmaceutical companies until I decided to go for environmental engineering field, and that's why I did the PM3 master. And I graduated in 2016, and since then I have been working for life cycle assessment, especially in the agricultural sector, and I'm currently employed at RIFCON, which is a scientific consulting company based in Germany. Yeah.
Thank you. And Cecilia?
I'm sorry, I was muted. Hi, everyone. My name is Cecília Bergman. I'm from Brazil. Actually, I did also the PM3 Masters for the batch of 2015. I am an oceanographer at base, but I have my master's degree in engineering, environmental engineering. Since I graduated, I have been working with LCA for Pink Strategy. It's a company, a consulting company based in Paris, France. And I work with life cycle assessment for the PV industry.
Thank you. Joanna?
Hello, everyone. I am Johanna Perez. I'm a chemical engineer from Venezuela. And I worked as a process design engineer for several years back in my country, and then did the master in environment and management and engineering of environment and energy, NE3, batch 2017. And I work with clean energy projects and climate change consultancy related to mitigation of GHG emission related to energy projects.
Thank you. And Salva?
Yeah. Hi, everyone. Thank you for joining us for the webinar today. Yeah, so I'm Salva Burhan. I also did my master's for project management for environmental and energy engineering, PM3 from France, and graduated in 2017. Since 2018, I've been working for Green Delta, the developer of OpenLCA software, which is used for LCA. So basically, I've been involved with doing a lot of LCA studies since then, and also implementation of databases and LCIA methods for the software. And also, I'm giving a lot of trainings and support for anything related to OpenLCA or LCA for the company. Yeah, thank you.
Thank you so much. And myself, my name is Astu Samprativi, and I have been working in the LCA for the last 3 years and focus in the LCA in geothermal. So I was working in a geothermal exploiter company in France. And nowadays I am a PhD researcher in the University of Geneva. I'm doing a life cycle sustainability assessment for the deployment of geothermal district heating and cooling in the state of Geneva. So yeah, so without further ado, we will start our webinar, our presentation. I give the floor to Patricia for your presentation. Go ahead.
Thank you so much. I will share my screen. Okay, can you see the presentation mode?
Yeah.
Okay, great. So yeah, I will start with the presentation talking about life cycle assessment for sustainable production. Just a quick overview what I will be presenting today. I will come up with a brief introduction to sustainability metrics. Then I will jump to life cycle assessment. What are the principles and possible applications? I will also talk about a European framework for life cycle assessment. It's the EU PEF. And also the life cycle assessment in the agricultural sector, which is what I've been doing the past years, and draw up some conclusions from them. So let's start with the beginning. What is sustainability? I'm pretty sure you're all familiar with the concept. However, I pretty much like this one. It is really involving the physical development and institutional operating practices in order to meet the needs of present users without compromising those of future generations, and especially with regards to the use and waste of natural resources, so really the environmental aspect. But why is sustainability now so important for organizations and for companies and industries? Well, one of the many reasons is, for example, the ESG investing. That is actually investors are looking not only at the economic performance of your company, they also want to look at the reputation of your company and how they're performing in sustainability with regard to environmental, social, and governance aspects. With regard to the environmental aspect, the life cycle assessment is really an opportunity to for the companies, because it's a tool to perform an analysis of your systems and your products that you offer to the client and how to communicate them. So I will now jump a bit deeper into the life cycle assessment. What are the principles of life cycle assessment? Well, it is as a method to calculate the resource use and the environmental impact associated with a product throughout its life cycle. But what is really this life cycle? Well, in order to have a product, you need a lot of stages, right? You will need some resources from either nature or recycled materials that you will transform into your product. Then this product will be packed and distributed to the users, where it will fulfill its function and eventually will be disposed, either through final disposal as incineration or reused. And in each of these steps, you will evaluate with life cycle assessment really what's going on and what are the emissions and how many resources you're consuming and how it is impacting the environment. So I will come now with an example in order to present really how it will look like in a life cycle assessment or a use case for it. And it will be the life cycle assessment of Christmas tree. So the question is, what is more sustainable? An artificial tree or a natural Christmas tree? A natural tree will be grown for around 15 years in a plantation forest. Then it will be cut, it will transport and sold to a household. It will be there for one Christmas season, and then it will be disposed either as compost or it will be incinerated for energy and then go to landfill. As to a artificial tree, well, it will be made of plastic, so you will need energy, you will need raw materials, and you will also be using it in a factory, producing it in a factory, and then it will be transported and sold to the household. You can use it more than one Christmas season, and then you will dispose it to incineration and landfill. So what do you think is more sustainable? It depends, actually. Let's assume that you buy a natural tree every year, and your neighbor is buying an artificial tree. So In terms of climate change, if you buy every year a natural tree, after 3 years, you will have the same impact as your neighbor who had the artificial tree. That is in the case that your tree is being incinerated. Let's say that you say, okay, I will compost my tree, that would be better. Well, after the 4th year, you will also have the same impact as your neighbor who had the artificial tree. In terms of renewable energy demand, however, your neighbor has the win. It will be the more sustainable. So with this small example, I just wanted to say there are some other applications for life cycle assessment. First of all, as I mentioned at the beginning, you can start supporting your sustainability strategy and looking at your operations inside and measure them. It can also contribute to product development and design in order to improve the performance and also the footprint of your product. It also serves the purpose of marketing and commercial purposes too, especially when we're talking about certification, labeling, and also the differentiation with compared to your competition. And also for decision making, of course, in value chain, which I think is the example of the Christmas tree. So where should I buy my Christmas tree? Where should I source? And what should I do with it? So now I would like to talk about some framework and policies of life cycle assessment, especially in the European area. It is the product environmental footprint, also associated or abbreviated as PEF. This project was born from different policies from the European Commission that were looking at or aiming at common methodology for life cycle assessment, especially for environmental footprint and for carbon accounting, and also for auditing this carbon accounting. And moreover, the final goal of some policies is also to have like a common framework for labeling of your green products, or if a product is environmentally friendly. So as a result, they developed category rules, PEF category rules for different industries and products. So these are actually technical guidances in order to perform this analysis, this life cycle assessment for environmental performance, and they are also a basis for communication with regard to many principles, such as the transparency and the comparability and the clarity of the analysis that you're doing. So how to present your results. As I mentioned before, it is available for different products, from photovoltaics to beer. But now I will talk about agricultural products, which is the sector I've been working in. And let's just go to it. So why is agriculture actually so important? I don't think I have to mention it, but you know, it is the source of feed, is the source of food, sometimes of fuel, and also for fashion even. And it also has a great impact on economy, but also on environment. So it is the source of most of the greenhouse gas emissions, or at least a quarter of them, but it's the main source of eutrophication of water bodies. Moreover, with regards to resources, it is taking already 50% of land worldwide and is responsible for 70% of water withdrawal. So it is really right now the center of attention for many consumers as well. So the public has its eye on this sector, and it poses a pressure for sustainability, let's say. So one of the challenges for the agricultural sectors, especially for plant production, is, well, agricultural systems are open systems. So they have a strong interaction and complex interactions with the environment. So they're susceptible to climate change. They're also susceptible to drought, to rain. And you also, whatever you do on the field, it will be in contact with the environment. So you have a lot of emissions that you cannot control most of the times. Moreover, as I already mentioned, there are coming even more regulations and policies on how to, how to grow your crops and so on. And all these challenges, let's say, are also translated for a life cycle analysis when you have to model actually these systems. So you need really environmental models and a lot of input data to represent this system. And moreover, you have to take care of specific impacts that take place with like agriculture, which is, for example, the impacts from land use change. So there are many, let's say, challenges to face, but one positive thing is actually the regulation and the framework that I already mentioned before, the PEF category rules. There is already one for feed for producing animals. So this guidance is a guidance for the analysis of animal-based ingredients such as fish oil, plant-based ingredients such as cereals, and other additives such as vitamins that will be mixed in a compound feed and given to livestock, for example. And we also have some flows that circle back, such as co-products, as the fish oil or manure that's going to be brought out to the field for plant production. So you can imagine the complexity of all these mass flows, let's say, but the critical category rules will offer a basis for modeling of all these emissions, and it suggests databases so that you can perform a life cycle assessment or an environmental footprint of the product. And it also suggests the relevant impact assessment that you have to perform and how to communicate the results that you have that you obtain. So this is a pretty good basis already that simplifies many things of agricultural models. I would also like to mention some of the improvements that have been achieved in the agricultural sector and that are also supported with LCA. With regard to the suppliers of agricultural systems, there have been the development of products that enhance the resource efficiency, for example, additives for the metabolization of nutrients or surfactants. This is all in order to reduce the use of resource and simultaneously also reduce the emissions that you emit to the environment. On the hand, for the farmers, what is also very useful is the certification schemes. The certification schemes provide for farmers sometimes accessibility to a market, a specific market they want to target, and also for grants or subsidies, and you will all at the same time be compliant with regulations as well. So what is actually life cycle assessment doing there? Well, most of the certification schemes will require that you account for the impacts that your operations enduring, especially with aiming to continuous improvement. So life cycle assessment will also provide a good basis for applying for certification schemes. So as a conclusion, well, let's start with the most important one. The life cycle assessment actually can really support different purposes especially in the private sector with regard to environmental footprinting. And although there are some methodological challenges, the life cycle assessment is actually able to represent agricultural systems and has been useful for the reduction of environmental impacts, but also it has been useful for business development and product development, as well for the economic improvement of farmers. And finally, the consensus and standardization through, for example, the PEF category rules, they contribute to the availability of data for analysis. This is for us, for practitioners, really good. It also facilitates the assessment and the availability of product footprint, especially for B2B communication or B2C, so that you have also a common ground and you have, yeah, let's say, the same language when you're talking about environmental footprint. So this is pretty much it that I prepared for you, and maybe I should stop sharing my screen, or if you have any comments. Thank you. Oh, I can't hear you.
Yes, thank you very much. Thanks for the presentation. So for those who just joined, maybe not since the very beginnings, Patricia has presented to us the life cycle stage. How is it useful in, in assessing the resource and the assessment and the resource and the emissions in every stage. And she was also presenting about the use of LCA in the product development, in marketing, and also to help decision making. And she was presenting to us as well about the PF, or like environmental footprint, that was developed by European Commission, that is useful for standardizing the carbon accounting and to establish the common framework for labeling, for example, going from PV to beers. That's like a wide application. And specifically, she was presenting also about the LCA in agriculture, because it has a high impact in not only in greenhouse gas emission and overall greenhouse gas emission, but also mostly in eutrophications. So thank you very much for the presentation. And Cecilia maybe can also present now about her experience of using LCA in solar PV. The floor is yours.
Yes. Okay. So please let me know. Are you seeing my presentation?
Yeah.
Okay. So now I will present. I will try to keep it simple. Thank you, Patricia, for the introduction. I work for the production of LCA for the solar PV market. I think it's important to talk about LCA for the PV market because actually solar PV is one of the most important renewable energy that we have now, as well with wind and hydropower. If we can see, you can see in the graph under the text. And actually, it's been growing and growing. It'll be growing for many, many years. We see when we talk about renewable energy, we talk about clean energy, but we don't take into account actually the energy and the impact we have to produce one solar panel. We talk about the life cycle solar panel. For one solar panel can have 25 years of life. So it means that for 25 years will produce energy for us. And we say that the energy payback time, it can vary between 1.5 and 2.5 years. It means that from this time on, we'll receive more energy than we use to produce the solar panel. But actually, we don't talk about where the solar panel and their components they were produced. We talk only about energy payback. And if you see in the table in the right, actually, when we compare the offshore wind with solar PV, the global warming potential of a solar PV is almost 8 times bigger than the offshore wind. Why is that? If we check how a solar model is built, if we take into consideration a cradle, I don't, for the French markets where I work for, we don't take into consideration the end of life. But only for an example, if we take a cradle to gate, meaning the extraction of raw material, the transformation of silicon to crystalline silicon, solar silicon, and after that, for the transformation from the silicon, the solar crystalline silicon to an ingot, and after the transformation of wafers converted to cells, and actually finally the cell assembly into modules with the glass EVA PT. It's a highly energy consuming process. Actually, we use mostly heat to melt the silicon and transform it into ingot, crystallizing the silicon, and it's highly energy consuming. So it's important to take into account even more than how much energy we use to produce a solar panel, actually where it is produced. It really matters because I will take into example 2 countries, 2 regions, sorry, Asia and Europe. And actually, if we take into account for the Asian market, China, I'm sorry, this is a really old data, but it's still valid. If we take into consideration the top production locations of solar panel in the world, China being the #1, when we check the energy mix of China, we see that 80% of their energy mix, it's coal. And when we compare, for example, an energy mix from Spain in Europe, that it's much more diversified, we can check into the table in the right that the gram of CO2 equivalent, the impact in the greenhouses emission by kilowatt hour used to produce 1 kilowatt hour of energy, it's much higher than China than in Spain. So what does it mean? It means that you have your solar panel or any part of your solar panel made in China, you have a much bigger impact of your solar module at the end. To exemplify it, I took the same module, a 60 cell monocrystalline module of 360 watt peak. If we have your whole module made in China, meaning the transformation of silicon into ingot and wafer and cells and the assembling of the module, you have almost 2,000 kilograms of CO2 equivalent emission per kilowatt peak, while when you have this module made in Europe, mainly in Europe, with energy mix much lower than in China, much more diversified, meaning that they have in their energy mix renewable energy or less coal, we can talk like that, you have a final impact that is much, much lower. This we can know when we do an LCA. That's why important to know exactly where your production are, your components are being made, and what kind of energy you're using to produce them. And we can calculate this with an LCA. So I'll just give a quick example for the French market. Actually, France is the first country that puts a limit on the calculation, puts a limit on the impact of a solar panel, meaning that the French government, they buy only panels that has under an impact of 1,150 CO2 equivalent per kilowatt peak. What does it mean? It means that France actually is limiting the impact of the panels that they put on their ground. Because actually they have attested that if your solar panel is produced with a highly impact type of energy, actually they consider that the energy that you produce for the next 25 to 30 years, they will not be compensated by the energy you need to produce the modules. So they take 20 to 30% of the final note for the public tender. It's based on the carbon impact, which I think it's really important, because sometimes we talk about in renewable energy, a solar panel that is supposed to be clean, and finally not always. So yes, I agree completely. The solar PV is one of the best solutions for clean energy, but also from an LCA, from knowing where your components, where your energy comes from, it has to be taken into account, and we can do that with an LCA. So I put the carbon payback time, not the energy payback time. Actually, it will depend more where your model is produced, the methodology used, where is installed, and it's much more important than the energy payback, actually. So thank you very much. I hope I've been clear. Please let me know if you have any questions.
Thank you so much, Cecilia, for the presentations as well about solar PV. So yeah, it is true that PV has been the technology that contributes the most as in terms of renewable energy to the energy transition. And it is interesting to know that you know, the stages of life cycle, and that one of the stage actually requires a lot of energy, like energy intensive, and unfortunately that the top production, the top country that produces this is still in China, which has a very high CO2 in their energy mix. And comparatively, it will account to like 4 times of the energy per kilowatt peak for solar PV. So that's really interesting to know, and interesting also to understand how France have adopted this LCA approach in their regulation, and that how they will not any tender that has a certain level of CO2 higher than a certain level of CO2 will not even be considered. So thank you very much for this insight. And the last presentation will come from Joana Perez, who is going to introduce us about circular economy and also how LCA is very useful in that. The floor is yours.
Thank you. Let me know if my screen is in. Okay, well, I would like to present a little bit of how the LCA can help implementing circular economy strategies, and how can these help making decisions, like data-driven decisions. For this quick presentation, I will present a quick overview on the concepts of linear economy and circular economy, some of the indicators for measuring circularity, and then I will give quick concluding remarks on how LCA plays a role in circularity. So maybe some of you know a lot about this, but for some of you is a new concept. But mostly the way we live and produce and consume is based on a linear model, which starts on resource extraction from nature, and then the production process, distribution, consumption on the side of us as society, and then we produce waste out of those products that we use. However, this model is basically broken. We have an increasing world population as never before in the history of humankind. We have an emerging middle class in countries that are developing at this moment, and they are demanding more products and services. We also have an established status of production and consumption on a very fast pace, and using artificial or synthetic or man-made materials. And of course, this is causing an important environmental stress on our nature's systems and compromising their ability to regenerate and provide resources. Also, and maybe this is a fact less known, we are almost collapsing our recycling and waste management systems even in developed countries as a result of this massive consumption and production of objects and materials. So what is circular economy? I would like to make this speech a little bit more of an open-ended reflection and food for thought, as sometimes it is referred, because I think this is a debate, and this is still not fully implemented, as you can see in your life, and I think there is a lot of room for innovation and a lot of room for experimentation in this area. But in general, what we understand as circular economy is a process where the raw materials enter the cycle of production and consumption through a way of designing better all the materials that we are using for our production processes, a more sustainable way of producing those products and distributing them, but also a change in the consumption patterns, trying to use, reuse, and repair our objects before passing to the next stage of collection and recycling. Okay. So basically, there are three principles that rule the circular economy concept. First is designing out waste and pollution, and this means that it is already has to be in the mind of the designers that every process will produce waste and pollution. So it's focusing the scope not only in our final product or the product that we want to sell, but also trying to get opportunities of producing valuable byproducts, for instance, or already embracing the idea of what to do with our waste. Okay, and the second principle, which is keeping products and material in use, the idea of this is to extend the lifespan of the product the longest possible, and keeping reusing the same materials instead of recycling it, Actually, the recycle is like one of the last stages that you want in a circular economy. You want to first reuse them or remanufacture them in a way. And this includes also all the effort in labor, energy, water, etc. It's not just the raw materials. And the third principle is to regenerate natural systems. And this is basically trying to go to renewable sources, both for energy and materials. And if it is possible, also generate a positive effect in the environment. For instance, for whatever production of food, if this is so within a circular economy perspective, the idea could be using, let's say, the composting systems to improve the quality of the soil, for instance. So it's not just an extractive system, but a system that regenerates itself. So I'm presenting here a very known graph by the Ellen MacArthur Foundation, known as the butterfly diagram, which deploys the two main streams of materials that make or the products that we use in our daily lives. So we have a technical materials or man-made materials which come from mining materials or other type of non-living sources. And that goes through a process of parts manufacturers, product manufacturers, service providers. And that interface, as when it comes to us as users, it is somehow, I mean, we have a role of the user, while the biological materials, which is in the green part, is actually a resource that is consumed. So imagine like a Tetra brick pack of a juice. So you have all the packaging, which is more technical material, but you have the biological material that you consume, and at the end of the life of this product, that will be that won't be available mostly for waste, but still you have the packaging. So from the blue part or the technical part, there are several strategies or several roads, let's say, to improve the circularity of the system. And this is mainly trying to minimize waste, okay, like zero waste. And same for the biological materials. So once it becomes a waste, then you can go through the other phases like extraction of biochemical materials from the waste, or anaerobic digestion, composting, biogas, and finally trying to get all these streams back to the earth. Okay, so having this in mind and having in mind the concept of LCA, for instance, for a normal LCA analysis, you will go mostly to the middle size of this plot, where you get all the raw materials, the manufacturing, the distribution, the consumption, and then the waste. But when you talk about circularity, you are expecting that once you use the product, you can take some of that material to be collected for recycling and take it back to the loop of manufacturing, or some of the components can be reused and be entered to the manufacturing process as a different stream of material. So you will have, instead of only virgin feedstock, you will have, let's say, 3 types of feedstock: recycled, reused, and virgin. So depending on your strategy on circularity, all the fractions or all these flows will have a different impact when you analyze it as an LCA system, for instance. And there are a couple of indicators for measuring the circularity of a system. One of them is the linear flow index, which is the proportion of material flowing in linear fashion over the total material flow, and the material circularity indicator, okay, which considers the LFI and also the length and intensity of use of the product. So, okay, this idea of understanding the material loops is great for understanding the concept of circularity. But closing these loops is not a guarantee for success for these circular economy strategies. And why is that?
I'm sorry, just to interrupt, you have 1.5 minutes to go.
Okay. Yeah, so why is that? Basically because the implementation of the circular strategies can also have energy use, water use that are not present in the linear model. So that's why it is recommended, or it's a good path to take into account LCA and circular economy models to allow measuring all the environmental performance of the different strategies and comparing the different strategies in a design phase. Okay. So basically, LCA can help implementing circularity first by developing a base case where we create the flow diagram as is in any LCA study. Then we define some strategies for the circular economy, identifying all the biological and technological flows and how these will impact the LCA model. Then you will integrate the MTA, the index that I mentioned before, into the calculation, the LCA model. And you can establish also some objectives. So what do you want? Do you want to reduce carbon, the global warming potential for the climate change, or reduce the NCI? You can create different scenarios for comparing your strategies, and with through analyzing and comparing the results for the different circular economy strategies compared to the base case, you can get like the best trade-off for the business. So, well, basically, I would like to close this intervention by saying that the LCA gives a good insight on the environmental performance, while the circular economy helps integrating the systems and integrating or closing the loops between both biological and technological cycles. Regarding the complexity of doing this analysis, well, compared to LCA, the input data is almost the same. So once you are doing an LCA, you can easily try to calculate some of the material circularity index or other circularity indicators. And basically, well, the LCA will help quantifying the improvements done by circular economy models, helping designers and innovators looking into matters that they may have not considered and make better decisions. So, well, that's my presentation. Thank you.
Thank you very much, Joanna, for the presentation. So, yeah, circular economy is a concept that has been, growing in the recent years, because it is indeed true that our linear economy concept is no more supporting our long-term growth. And yeah, you were also introducing as the circular economy as the way to keep the resources in the loop as much as possible, to have a system that regenerates themselves. And so the best way, of course, we have to develop a strategy, and then the best way to have the strategy is to have it on the design phase, and then instead of like tackling it already when the system is ongoing. And yeah, you provide a lot of insights about circular economy. Thank you very much. And now the floor is open for question and remarks. If you have any questions, please put it on the comment sections. But before we go into that, I would just like to add, it is interesting to see how LCA has evolved in the energy system, like PV, and how circular economy has also, growing now in the literature and also in the day-to-day application. I myself, as someone who is doing LCA on geothermal, but I also look at more on an energy system, that we look into CO2. CO2 has a very two-way attention, and then sometimes we forget about what other impacts are there, and this is also where LCA comes into play. And what I learned is that about this material, like the material that we actually need to have a good energy transition, to have a long-lasting energy transition, we also have to take care about this material that we need, because it's really interesting to see how materials and energy and also the CO2 and the carbonization strategy come into play. Probably Salwa has some feedback about this, about what our presenters just presented.
Hi, yeah. So thank you, all three of you, for the presentation, and it was very good to understand like how in different sectors how LCA is being taken and what kind of study has been made. And yeah, that was very interesting to see, especially for example, for Johanna, how like this is one of the methodological tongue twister for me. complications that's part of LCA is, yeah, like how it's a linear model. So, so it's also a very good step that, circular economy helps and augments LCA to better understand the different implications of, our products and processes. And yeah, for agricultural, it was very good to see like what exactly are the impacts and how the differences are coming when basically from the decision of the production or consumption. So it's very nice. For Cecilia, I think it was very good study, and I think someone also asked a question on the end of life for solar PV. So I'm also kind of curious to know what is the answer Cecilia is going to give for that. So let's see.
Thank you so much. So
Yes, actually,
yeah,
I'm sorry,
carry on.
Astu.
No, carry on.
Yes, I have not taken into account because, as I said, I gave an example for the French market, and that's what I work right now. The tender specification, they don't ask us to take into account the end of life module, nor the impact of the frame, aluminum frame. That's why I didn't put it. My examples, my calculations, they are based on the LCA, but they don't take into account the end of life. I work also with the PEP. It's a product environmental profile. They take in this study, we take into account the end of life recycling and the transportation to the installation of the solar panels. That's why. But normally, yes, of course, when you do, but because the French tenders, they are based into ISO 4044, but they have their own methodology.
Maybe I would like to build up on these questions. It's like sometimes we cannot really do the assessment because the data is not available.
Exactly.
So I would like to probably, I don't know, from your experience, guys, what is the availability of data on the end of life sections? Because even like we recently heard also about the blades of the wind turbines that have compiled, and now someone has to find a solution to kind of like recycle, reuse, or treat this instead of just piling up in the landfill. So do you have any knowledge about this of database availability and other challenges about this?
For the one study that we have done for the PP that we had to take into account, it was in the Netherlands. We had a lot of problem finding this information because what we do, for example, we do this study for one solar PV producer that actually he doesn't know exactly where his module will go. They have their client that buys the module. We don't know exactly where it's gonna be installed. So what we do is we take default values. It's normally they're not. They're the worst case scenario. There will be a little bit worse than the real values that we could have if we had the right information. But when we don't have the right information, we have to make assumptions.
Okay.
I'd like to add to that also that in most scenarios for renewable and energy-based industry, basically, so many of these energy production systems have long lives, like 25 years and more. So in that scenario, we don't even know, like if something is going to be dismantled in 2050, like 2050, the technology is not even known. So it's really based on assumptions. So you all have to already take like, 3 different scenarios, something like that. And then based on that, you have to make some kind of analysis and then, make the study.
All right.
For end of life, yeah.
Okay.
But that's like the best option that we have right now.
Yeah. So thank you. And then I'm going to start picking up questions now from YouTube. There is one question from Alejandro Figuera, and it is directed to Patricia. So do you have any opinion about the difference GWP 100 and GWP 15 instead of different emission factors?
Well, we are very stick to the frameworks, the current frameworks that are also used in Europe, and they are really focused on this 100-year GWP, sorry, and it's really based on the last release of IPCC, the AR5, I think, and they are not even taken. I mean, the current PEF is not even taking into consideration the biogenic assimilation or the biogenic emissions of CO2 in this case, unless they are being taken for over 100 years. So, yeah, I think we always go for the GWP 100 in our case, at least for our industry, because also these are fast moving consumer goods. This agricultural products. Yeah.
Okay. Okay. And then he also asked question, do you think LCA already represents agriculture in a fair way? Because soil organic carbon is not in the IPCC framework, but we know that soil sequesters carbon. So yeah, so he doesn't think that IPCC takes this into account. What about your study?
Yeah, well, I do think it represents us in a fair way. In my opinion, of course, there are limitations. There are things to improve, especially with regard to toxicity of heavy metals and so on. That's another story. But I think that it is already a good basis for the analysis, and it provides already good information for stakeholders. And with regard to the soil organic carbon, well, it's very difficult to find there also a framework. I can imagine that there is no magic solution or methodology for soil carbon. It will always depend on the location. It will depend on the type of soil. It will depend on the layer of the soil you're talking about. And I think for cropland, if you're doing arable land, you will never significantly sequester carbon, because every year you are moving the soil and releasing the carbon again. So the problem with that is that would be, I think, relevant for forestry, maybe, because you are really keeping your crops or your biomass on the ground. And the problem is that you also need a lot of data. There are a lot of models right now, but each model is more complex than the other one. And you need primary data for that. And I think that's a huge limitation. You're right, especially for land use change. Sometimes you have to go, as Cecilia already mentioned, for default values, for simple methodologies, because, as for completeness sake, let's say. But to achieve really like the granularity that you need, it's very difficult. Yeah.
Okay. So I hope
I
that
had one question related to that. For some of the agricultural studies, LCA studies that I've seen, a few of the papers have also used the ecological scarcity method, you see. So do you know anything about that? Like, that is also, I've heard, like one of the more used for agricultural sector, at least. Like even these databases, like AgriFootprint, if you know, AgriBalise. So I think they mostly, people who are using that are using ecological scarcity method as one of the LCI methods for calculations. So do you only use IPCC for now, or do you also explore other methods just to, understand, like if they are more accounted in these other methods?
No, well, we are currently using a lot of IPCC, for especially because of PEF, because it's recommended by PEF and also by the UN. So
and not the EF method?
The what?
EF method.
The PEF. Product environmental footprint. So I'm not aware of this ecological
scarcity method.
What's it? Scarcity? No.
Ecological scarcity method, you can take a look.
But is it related to biodiversity or something?
Yeah, I think, it's mostly for ecological, resource use and all that, I think. So it's more, you can, take a look.
Yeah, it's all connected, let's say.
Yeah.
So we can see the interactions of LCA practitioner here. I'm going to move to the next question from Alejandro. But this time it's related to circular economy. He asked, do we take into account the reductions in global warming potential, of the displacement of raw materials caused by use of byproducts? I think this question was asked when Joanna was presenting. I don't know if it's something that you can comment on.
Yeah, I can make a comment. Yes, of course. Like global warming potential is another environmental indicator, as many of those available in LCA. And any analysis that you do of any system, you can take the global warming potential as any other impact, as acidification or any other. And regarding the last part of the question of the displacement of raw materials, basically the model that I showed in one of the slides, where now the raw material is not just virgin material but also reused and recycled ones. It is expected that the LCA model will have like an equation where it deducts somehow that fraction of material that is not being taken from the nature.
Mhm.
Okay, so I don't know if I'm answering the question, but basically yes. I mean, you will be using for the same output or product, you will be using less virgin material. So in a unit base or relation, it will be reflected, of course.
Yeah. Yeah, I think this really depends on in LCA. What would matter the most is also the scope of analysis. So it's really for the practitioner to define what is the objective and therefore the scope of the analysis. So I would say, if I can comment on that, I would say yes, you can, and if that is also in your analysis, and that will be something interesting to look at.
And I would add also over the discussion that we were having previously, I think LCA is very useful for scenarios and comparisons. So sometimes when you want to have a debate over GWP 15 or 100, I mean, it is important, but it's also important to try to have the same basis for comparing different systems and try to make the most educated decision based on the data that we're getting. Understanding that there are limitations, there lacking data. Also, the system has to be like the same boundaries for every system that you're comparing, and those are very important aspects of the practice of LCA.
Yeah, it's very valid point. That's true.
Yeah.
So I'm going to move to the next one. This is actually quite interesting. In my head, maybe Salwa can answer this, but anyone can also add to this. Thanks for the presentation. Could you give example of industries where LCA has not yet been implemented, either due to the process complexities or inertia to change, or maybe other reason?
Maybe more than inertia to change, I would say it's the complexity or the newness, because in the end of it all boils down to if you have the data to make these LCA studies, you see. So I think like I have, like from what I know, I've seen study for energy, agriculture, what was that, semiconductors, but then I think semiconductors is one of the field where it's a bit difficult, mostly because of data problem. Nanotechnology, it's a very new field, things are very dynamic, so I think these are I think this is one of the field. And then also when you think about plastic litter is a very critical aspect right now that is not somehow considered in LCA. So there are a lot of projects going on, like one I know is Murray LCA. I don't know if you've heard of it, Astu. Yeah, so all these studies are going on to be maybe able to integrate new data, and then that I think that's one of the areas where we don't have much LCA.
So basically, maybe this industries in emerging technologies, right?
Yeah, exactly. More so.
Yeah.
But like everything, like I mean, from tampons to I don't know, beer, everything is being covered. Like you really see a lot of different paper cups, everything. So it's pretty interesting, the studies that are right now taking place.
Right. Yeah.
I would like to just make a comment. Also, it's really hard to do LCAs for industry that have really secret processes.
Mining. Yes,
Yes,
mining.
exactly. So I think this is also why for some sectors there are not a lot of studies and not a lot of information. Confidentiality.
Yeah.
If you want to do any study on platinum mining, please change your job.
Yeah.
Also,
Okay. Yeah.
I would add that as far as we don't have regulations like in all the countries of the world or something that make the companies do this analysis, of course, maybe that would be passed as something not so important at certain points.
So you're suggesting that there should be more regulations in to make these companies do such studies.
Yeah, I mean that could be helpful, but I'm just highlighting the fact that for those sectors, companies or industries that we don't know their LCA results, maybe it's also the lack of something that is pushing them to do it.
Yeah, motivation. Yeah.
Right. Interesting. So we have one more question from YouTube, and maybe this is towards Joanna. In the context of a leading circular economy and sustainability assessment in the same way, right? How can we possibly increase the material circularity of outflow?
Yeah. Well, the material circularity, which is basically an indicator of what portion of the material in the loop is from the loop, is not from an outside source. There are several strategies. Okay, this includes also like new business models, new ways of designing the product in a way that it can be deconstructed somehow, and some parts can be reused as it, or made of single type of material, like from cardboard, only cardboard. Because as long as you complicate the composition of a material, it makes it harder to be reused or to be recycled. Okay, so there are several strategies, and I will invite you to check the Ellen MacArthur Foundation for further information on this. But
Can you repeat again? This is Ellen MacArthur.
Ellen MacArthur Foundation.
Okay.
Yeah, it's one of the leading sources. Like it's grabbing all the information that is being generated right now in this topic, and they have explained like maybe 10 business models of how to do this, and there are several strategies. I mean that's the point. And at the end, like mathematically speaking, the idea is to increase the amount of reused or recycled materials in the flow. That's how you will increase the material circularity.
Okay, interesting. So yeah, we are closing to the it's 1 hour already passed since we started this webinar. Maybe I would like just to have a brief closing remarks from all the practitioners here, as in if someone wants to wants to work on the LCA or to want to know more about LCAs and their applications in energy policy or even for their own decision making, what are the resources that they can get from? I mean, where are the resources that they can get from? Or is there any institutions, is there any forum or web pages that people can go and learn about LCA? Is there any certifications?
Can I start?
Yeah.
Yeah, I think firstly you can. There is this organization LCIC. I think. Ashtu, you're also part of that, right? Am I correct? It's LCIC. Yeah. So they are actually hosting a lot of information, training, and also like opportunities where you can learn, and online courses, I think. And also with UNEP also hosts some. If you just Google UNEP LCA, they will guide you. I mean, Google will guide you to the right pages. I think that's one of the options. Then of course, like different LCA software providers like OpenLCA, GAB, Easy Macro, they all have their own short tutorials, webinars, where you can learn how to just get like the basic information on how to get started, and also different information, like for example, also eco-invent, like because when you're making an LCA study, you use different databases, and eco-invent is one of the most widely used. So and then when you want to work with systems which are multifunctional, multi-output processes, and then there are these different system models. Okay, I think it got too complicated, but basically, if you want to understand like the basic differences in the database, what information it's providing, and so all that, I think you can get in those, in the website of the database provider or the software provider, or even the LCI method provider like IPCC, Recipe. These are some of the more commonly used, CML, Dutch LCI method. So yeah, I think these are very useful resources to get started.
Okay, thank you so much. I'm tapping it. And then what about other speakers? Do you have a recommendation of what sources to go to learn about LCA, circular economy?
I think Salwa already did a good summary on that. Yeah, and
Okay.
can't recall anything.
Right. Okay. Well, I think I'm going to close the webinar now. Well, I would like to really thank every speakers for the interesting insights, and also for whoever has been joining from YouTube. And stay tuned with Emanate. In June, we are going to have a webinar regarding business and failures, who are going to be presenting, be presented by two entrepreneurs from the PM3 and ME3. And last but not least, I would like to wish you Eid Mubarak for whoever is celebrating Eid today. And hope it's like a full of blessed for your families, and you celebrate this with a happiness with your families. Thank you so much, and see you next time.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.